So in this video, we're going to talk about the volumes, of solids generated by revolving the curves or the regions about the lines. Okay. So we're doing it. We're doing the integration about the y-axis. So we're finding the volumes of the solids generated by revolving the regions bounded by the lines and curves. Okay, about the y-axis. So let's look at a simple one. So what if you want to find the volume of the regions where x is equal to the square root of 5 y squared, x is equal to 0, y is equal to -1, and y is equal to 1. Okay, how do we revolve this around the y-axis? Well, again, to me, it's always important to draw a sketch of what the graphs look like, but again, it's not required. Okay, so we know the line of x is equal to 0 is actually the horizontal line here. So that is x is equal to 0. We know the line of y squared, it's a parabola shaped to the y, but we have the square root of 5, which just narrows it down. So we could approximate that. It looks something like this. Okay. And we know the line of y is equal to -1 looks something like this. Okay, and y is equal to 1 looks something like this. Okay, and we're asked to find the regions bounded by the curve here. Okay, now to me, it seems as if the limits of integrations are already given. Okay, so we know the general form is that I'm going to take the integral of pi big R squared from a to b, okay, where big R is a bigger function, minus pi little r squared, where little r is a smaller function, okay, and we're going to integrate this in terms of y, so dy, okay. Now in this case, if we walk along the y-axis, we can see that our upper function is given by the line square root of 5 y squared, okay, and the lower function is given by 0. Again, anything minus 0 is, 0 we don't care about, so really it's just the integral of this function here. So if I set my integral, this looks like the inner limits of integration with respect to the y is given. So this is from -1 to 1 of pi. Well, what's my r? It's the upper function squared. What's my 0? What's my lower function? That happens to be 0 along the line of the y-axis. So this is pi r, which is 0 squared dy. Now, here's a little trick that we're gonna I think we already talked about, but let me reemphasize. Anytime you have your limits of integration to be symmetrical, so -2 to +2, -1 to +1, what you could actually do is to start the integration from 0 and go up to the positive number. So I'm gonna multiply by 2, because essentially you're doing 2 times the integral. So I could rewrite this from the integral from 0 to 1 of 2 times pi the square root of 5 y squared, and again this is just 0 and this is dy. So our limit, so our integration will now look something like this. Okay, now if I square this, okay, this becomes 2 times from 0 to 1 of pi. Well, the square root of 5 squared is just 5. Okay, the square root of not the square root, but square root of 5 squared is just 5, yeah, and then y squared is just what? We're just adding our exponents, so this becomes y to the 4th dy. Now again, pi is a constant, so I could factor it out. So this becomes 2 pi from 0 to 1 of, well 5 times 2 pi from 0 to 1 of y to the 4th dy. Okay. Now when I take my integration, I could simply say this is 1/5 y to the 5th integrated from 0 to 1, and don't forget this is all being multiplied by 10 pi. Okay. This is all being multiplied by 10 pi, which is what we have here. Okay, so now I'm just going to plug in my values. So this becomes 10 pi. I'm going to keep that outside, and I'm going to plug in my upper limiters. There's just 1/5 to the 1/5 minus 1/5 times 0 to the 5th. Okay, we know this is 0. Okay, and we know 1 to the 5th is just 1. Well, that's just 10 pi multiplied by 1/5. Okay, and we could simplify and say this is actually 2 pi. So the volume in this case would be 2 pi. So let's look at another one. So what if we wanted to find, what if we were given the region enclosed by x is equal to the square root of 2 sine 2y, where the limits of integration are already given, pi over 2, and x is equal to 0. Well, again, in this case, it's helpful to draw a picture. However, I do not know what this function looks like. And so that's why it's not always like mandatory for you to draw a picture. So I don't know what this function looks like, but I know I'm given the limits of integration, and I know I have the two curves, right? X is equal to the square root of 2 sine of 2y, and x is equal to 0. Okay, so how could we figure out which curve is the highest? We just take a number between the limits of integration and plug in, okay, and see which number gives you the highest number. Well, it's pretty important to me that any number I plug in between this, I'll always get a higher number than 0. So therefore, the integration now becomes from 0 to pi over 2 of pi r, which would be my upper function, okay, square root of 2 sine 2y squared dy, right? Because we're going to minus that from the lower function, which is 0. So that's pi 0 squared, which is just 0. Okay. So now the integral becomes something we could play with. So this is now equal to from 0 to pi over 2 of pi. Well, the square root of 2 sine of 2y, it just gets rid of the square root. If I square that, it just gets rid of the square root. So this is so pi is multiplied by 2 sine of 2y dy. Okay. Now 2 pi is a coefficient, so I could factor it out. So it's just a number, so 2 pi times sine of 2y dy. Now it just comes down to taking my integral. What's the integral of sine of 2y? Well, I have to take out a 1/2 out of here, so this becomes 1/2. The integral of sine is negative cosine, so this is negative cosine of 2y, integrated from 0 to pi over 2. And we know negative cosine of 2y, negative 1/2 cosine of 2y is all be multiplied by 2 pi. Okay, notice if I take the derivative, I get exact sine. Okay, if I take the derivative of cosine of negative 1/2 cosine of 2y, well, this is sine of 2y times the chain rule, which is just 2. So therefore, well, and it's negative, right? The integral, the derivative of cosine is negative. So I'll get my original integral back. Okay, so now it just comes to plugging in numbers. Okay, so if I'm looking at this, I could factor this out, so I could simplify this, and this becomes negative pi outside of cosine of 2y integrated from 0 to pi over 2. Okay, so now I'm going to keep my negative pi outside, and this becomes cosine of 2 times pi over 2 minus cosine of 2 times 0. Okay, well, this simplifies. Okay, so the negative pi now becomes cosine of pi minus cosine of 0. Okay, 2 times 0 is just 0. Well, if I'm looking at this, becomes negative pi. Cosine of pi is negative 1. Cosine of 0 is 1, and we still have our negative. So now this becomes negative pi. This becomes negative pi times negative 2, and negative times a negative is a positive, so we get plus 2 pi. Again, so these are simple integrals about the y-axis, volumes that we should be able to get, and that's the general idea.